Welcome to the presentation of WiseUT, an intelligent framework for unit test generation. Unit testing is vital for software quality, but writing tests manually is tedious and time-consuming. Traditional search-based methods use heuristics to automate test generation, while LLM-based approaches have recently shown great promise. Yet, they still suffer from limited coverage, weak defect detection, and poor semantic clarity, often caused by hallucinations and missing context. WiseUT tackles these issues by combining LLMs with program analysis, providing precise context and reducing hallucinations. Here's the workflow in brief. Extract scaffolds and helper methods from the AST and synthesize them into a test prefix, ensuring valid tests. Perform object construction and branch dependency analyses via the call graph to boost coverage. Apply type constraint analysis and detect potential error patterns to improve defect detection. With this enriched context, invoke the LLM to generate tests, then validate them iteratively with correctness checks, coverage feedback, and exception filtering. Finally, refine the tests for clear naming, documentation, and maintainability. Through this process, WiseUT delivers high-quality tests ready for developers and CI/CD pipelines. Now, let's see WiseUT in action. Since some steps take a while, we've trimmed the waiting time for this demo. At the root of the project, the main config.json file defines all configuration options. It has 3 sections, matching the 3 optimization dimensions of WiseUT: coverage, refinement, and defect detection. Starting with coverage, model-related configs are listed first, then path mappings defines the projects under test, including their names, paths, and source test directories. WiseUT supports different levels of granularity. You can generate tests for a single method, a class, or the whole project. Here we use the create container method in the non-generic class of the char project. Let's run WiseUT. It begins with program analysis, building call graphs and extracting branches and object dependencies. Next, it runs existing tests to see what's uncovered, identifies our focal method, and calls the LLM to generate candidate tests. These are executed, validated, and the valid ones form the final suite. The suite is saved in the project's test directory, keeping the original structure. Extra details such as prompts, responses, fine-grained coverage, go into the detailed res info folder, providing the user's comprehensive information. The generated tests achieves 100% line and branch coverage, demonstrating effectiveness. Now, on to refinement. Configuration is almost the same. WiseUT refines existing tests in the specified test directory. Let's take the previous LLM-generated tests as examples. WiseUT collects all cases, applies purification, then textual refinement for each one. The refined tests now have clear names, comments, and documentation, making them far more readable and maintainable with better semantic clarity. For safety, originals are backed up in the origin test backup folder. Upon validation, their coverage remains identical to before refinement, so no validity is lost. Finally, defect detection. At this stage, WiseUT supports Python type error detection. Here, we use the Python project Luigi. After setting the source Darren module in the configuration, we run WiseUT. It parses the project into an AST, identifies modules and functions, then uses Jarvis to build call graphs. Note that this can take a long time. To save time, we used cache data here. WiseUT then finds testable call chains, runs type analysis with 2 separate agents, and generates candidate tests. Each test is executed and refined. If it passes or finds a bug, the system moves on to the generation of other chains. The results are stored in the data generated tests folder in the defect module, as a .json file with coverage, test outputs, and execution details for each test. That concludes our demonstration. We hope you enjoyed it.